MoCA is a home networking standard developed by the Multimedia over Coax Alliance for distributing video inside the home. A derivative version of MoCA is also deployed in China by Entropic Communications in a similar way to C.Doxus is a version of Doxus, and C.HomePlug-AV is deployed by companies like Qualcomm Atheros. It's a version of MoCA that is targeting the access market for distribution to MDUs inside the home. I am here representing MoCA, the Multimedia over Coax Alliance, to talk about home networking inside the home, which is different from Ethernet over coax, the solutions that are outside the home, like HiNoC, for example, and the other standards that I mentioned. Now, the reason that MoCA, or even the access version of MoCA, is so popular is because MoCA is very, very robust. The key feature that MoCA brings to cable operators and satellite operators and telcos is very high speed and very robust, disruption-free, high-quality networking. And the reason that that's very important is because for video, you can't have any glitches in the video, for premium quality video. If you're watching on an iPad or a tablet or your phone over wireless, then it's okay to have glitches sometimes or disruption. But if you're watching high-quality HD television on a big screen TV, then you want glitch-free, no problem, perfect resolution, HD quality video. That's what MoCA is designed for. And to date, MoCA home networking is deployed in the US by almost all of the major service providers, including in the cable world, Comcast, Cox, Time Warner. In the satellite world, DirecTV and Dish Networks, the huge satellite companies. We also have deployments by Verizon, by Liberty Global and UPC in Europe, by DirecTV, Panamericana in South America, and also in Canada, a number of service providers that are deploying in Canada. The reason for the rapid growth of MoCA worldwide is because of the quality that it gives to the video. It took a very long time for service providers in the United States to select a technology that could meet the needs for high-definition video distribution inside the home. Many, many years. Eventually, they selected MoCA because of its quality. And that's why you see almost 20% in the US market, 20% of all homes now have MoCA. And the estimates are that by 2015, just 2 more years, there will be over 35 million homes worldwide that have MoCA. So that's the reason for the rapid rise in MoCA networking technology worldwide. The same is true in China for EOC. With the Next Generation Broadband Initiative, everyone is trying to bring high bandwidth, high quality video to the home, to the apartment building, any way they can, and coax is the best way to do it. There are still a number of technologies that are used. SARFT is in the process of standardizing HiNoC, but in the meantime, there are variations of different technologies that are used to address that need. But as I said, the reason for the rapid growth of MoCA worldwide is very simple. It works. It works all the time. It works at every coax outlet in the house. And really the key to MoCA is not just high throughput. The key to MoCA is high outlet coverage. And what that means is if I can show you that I can give 500 megabits per second on Wi-Fi, but it only works in one room, and it doesn't work in the other rooms in the house, and I only get a few megabits per second, then I cannot deploy a service that's high quality, that's premium content, because it won't work all the time. What MoCA gives the service providers is not just high bandwidth. MoCA 1.1 is 175 megabits per second of net throughput, very high bandwidth. MoCA 2.0 is 400 megabits per second of actual throughput for all applications and video. What it brings on top of that is high outlet coverage. That means MoCA works everywhere in the house that there is a coax outlet. So because it's so robust, you have disruption-free video, service providers can deploy high-quality HD content without any fear that there'll be any service interruptions. I would say that MoCA has really proved itself in the last 5 years. I mentioned already deployments by almost all of the major service providers in the United States. In the last 1 to 2 years, we've been very excited to, in addition to North America, to see deployments in Europe, in the Netherlands. Liberty Global is one of the largest service providers in the world, and they are adopting MoCA in their Horizon box. That's the name of their box. Recently, in January, DirecTV made announcements about their service deploying with MoCA in South America. So we're very excited that MoCA is now deploying worldwide. There are trials and interested service providers in Southern Africa and in parts of Asia, basically throughout the world. So I'd say the focus from MoCA this year and next year is really worldwide, expanding worldwide deployments. A focus in China because the market is very large. There's an emphasis on high width, next generation broadband requirements, and the market growth in MoCA for video is just phenomenal. The number of pay TV subscribers in China is already larger than any other region in the world and growing faster than any other region in the world. The amount of HD video subscribers that are in China is growing faster than anywhere in the world. So it's time for a network inside the home to support multiple televisions, multiple multi-room DVR, make wireless better by using MoCA as a backbone inside the home, and just reaching the same point that the United States operators and others around the world have seen with a high-quality, robust video networking solution. And in addition, one of the reasons that it's grown so fast is because so many service providers have adopted MoCA that many OEMs started making boxes with MoCA and developed understanding, and also many semiconductor companies. So right now, there are multiple semiconductor companies developing silicon for MoCA, many semiconductor companies that are in the alliance, including Chinese semiconductor companies. So we think the opportunity is now for MoCA to gain traction and start getting deployments by service providers in China, and that's why we're here. That's why we're focused on China and also on Latin America this year and in the next few years to show the service providers and the media what is MoCA. Why is MoCA so successful in other parts of the world? What can MoCA do? There are many new types of services that are starting to be offered, not just in the US, but around the world. IPTV services, over-the-top services, second screen, multi-screen applications where maybe you're watching video on your television, but you also have an iPad or a tablet or your Galaxy phone in front of you, and you want to get simultaneous information about the video that you're watching. Much more broadband coming to the home. Wi-Fi greatly improving the throughput capabilities. So the advantages that MoCA brings in this type of environment where you're moving video throughout the home and you've got a lot more bandwidth is a very robust home network for video. If you can handle video, you can handle data. You can handle anything. So MoCA brings this robust, disruption-free, high quality of service network which can make Wi-Fi better. For example, if you have a MoCA backbone inside the home and you've got 2 Wi-Fi access points attached to your MoCA network, then you have much improved coverage inside your house. So MoCA can significantly help improve the coverage of Wi-Fi and, of course, help with additional video technologies like IPTV, more high definition, 4K, 8K, the next generation of video resolutions that are coming out that require much higher bandwidth, 3D television. The need for bandwidth just keeps growing. And so as the bandwidth needs keep growing, the need for a robust, high-speed network inside the home continues as well. And MoCA, as I mentioned, MoCA 2.0 is now supporting 400 megabits per second of net throughput. So with that, you can have many streams of high-definition television. You can have 100 megabits per second, or 300, or 500, or a gigabit per second of data almost coming through. In addition, MoCA 2.0 supports channel bonding, like DOCSIS. In channel bonding, you can take 2 channels, put the channels together, and you double the available bandwidth. So instead of just 400 megabits per second, you now have 800 megabits per second. So MoCA in addition to meeting the current needs of service providers and being very robust, also meets the next generation requirements of service providers that are close to a gigabit per second of video inside the home, not just in one room, but everywhere inside the house. For content broadcasters, pay TV operators, and the whole ecosystem that surrounds them, including OEMs and the semiconductor companies. That's why you see so many companies from around the world that are here. It's the primary show for China specifically, but also beyond China in Asia. So we are honored that we were able to present one of the keynote speeches at the CCBN conference. Our goal is to evangelize MoCA, explain to media, explain to service providers, explain to OEMs what is MoCA, why is MoCA so successful in other parts, what does MoCA accomplish, and how is it able to do so. And CCBN has been very good. It's given us the opportunity to talk about our technology and develop a partnership that can help MoCA amplify our voices inside China. Let me explain about how MoCA technology works. MoCA 1.1 is a technology that sits at high frequencies in the spectrum on the coax. It has a range anywhere from about 500 megahertz to about 1500 megahertz. And the reason that it's so flexible is to allow the technology to support both satellite and cable operators. Cable operators use frequencies below a gigahertz for their video signals, so for the home networking they need to use frequencies above a gigahertz. Satellite operators use the signal above 950 megahertz to bring their satellite signals into the home, so they need to use MoCA signals below 950 megahertz. So the MoCA spectrum is very flexible. MoCA 1.1 is a 50 megahertz signal that is OFDM. And OFDM stands for orthogonal frequency division multiplexing. It's the modulation that's used in almost all modern standards and is a very powerful and effective way of combating multipath inside the home. MoCA is able to operate backwards through splitters inside the home. And this is very important because when you run on coax, you're talking from one room to another room. And somewhere inside the house, you have to go backwards on the coax. And the reason it's able to do this very effectively is because of the way the signal is constructed and because of the OFDM modulation and the forward error correction that is on top of the signaling as well. In addition, MoCA has very low latency. The average latency for MoCA 1.1 is about 3 milliseconds. And why is this important? This is important because video cannot be retransmitted. You don't have time to retransmit video. You need to have a very low packet error rate, and the video needs to get through very quickly. Also very important for gaming. You need to have a very quick response time so that you don't have any latency or lag. So MoCA provides low latency, very low packet error rate. MoCA 1.1 is 10 to the minus 5 packet error rate, which is very good for video. MoCA 2.0 expands the bandwidth to 100 megahertz, which gives you 400 megabits per second of net throughput, and also allows channel bonding of two 100 megahertz channels, giving you about 200 megahertz of total bandwidth and 800 megabits per second of net throughput. MoCA 2 also reduces the latency even further, and both MoCA 1.1 and MoCA 2 provide very robust quality of service capabilities where you can actually guarantee the amount of traffic that is going to get through for a particular video service. If we compare MoCA to other technologies, you can see why MoCA has been adopted by virtually all of the service providers in the United States. The reason is really robustness. If you look, for example, at Powerline, solutions for Powerline were designed for home networking. And you can show that sometimes they can get very good, very high throughput. The problem is they don't get the high throughput most of the time. This is where outlet coverage comes into play. Outlet coverage, once again, means how many rooms are you able to get that very high throughput in. And for Powerline or Wi-Fi or phone line networking or anything that's not coax, in some rooms you might get very good throughput, but in other rooms you may not get very good throughput, and you could get very low throughput or no throughput at all. What MoCA gives, that's the benefit to the service providers over all other technologies, all other wires inside the home, is a very high outlet coverage. So you get that high net throughput throughout the home. That's really the advantage that we see worldwide with MoCA deployments. 400 megabits per second net throughput for MoCA 2, 3 milliseconds average latency, very high quality of service, and also full interoperability between MoCA 2 and MoCA 1.1. And what that means is that a service provider can deploy MoCA 1.1 now, and if they decide down the road that they want MoCA 2.0, they can deploy MoCA 2.0 and it will work seamlessly with MoCA 1.1 products. CC.